All right, this is part 4, and hopefully the last of section 4.9, dealing with antiderivatives. So here I'm going to just talk about the introduction to differential equations here, and how integrals are used here as well. An equation involving an unknown function and its derivatives is called a differential equation. Now here's an example to get us started. Let's consider a more general differential equation of the form f prime of x is equal to g of x, where g is given and f is unknown. The solution f consists of antiderivatives of g, which involves an arbitrary constant. In most practical cases, the differential equation is accompanied by an initial condition that allows us to determine the arbitrary constant. Therefore, we consider problems of the form f prime of x is equal to g of x, where g is given, and f of a is equal to b, where a and b is given. So f prime of x equal to g of x, that's your differential equation. F of a is equal to some constant b, a and b are given, that would be your initial condition. So a differential equation coupled with an initial condition is called an initial value problem. Now, let's look at a few examples of this, where we're going to find not only the general solution, but also going to find the particular solution of that equation. Here's the example. For the function f given below, find the antiderivative, capital F, that satisfies capital F of 1 equaling to 0. So as you can see in this case here, we are given an initial condition. This F of 1 equaling to 0, that is your initial condition. And we're going to find the antiderivative f. Here, we're given lowercase f of x is equal to x to the 7th minus 3x to the negative 4 plus 5. So that means that capital F of x, we're finding the integral of f of x dx. And f of x in this case is this. Bring down the integral symbol. Replace that with x to the 7th minus 3x to the negative 4 plus 5 dx. And of course, we'll use the sum rule on this, sum indifference rule to be exact, and also the constant multiple rule. This will be the integral of x to the 7th dx minus, and I can pull the 3 out in front, times the integral of x to the negative 4 dx plus the integral of 5 dx. So here we just take each integral one at a time using the power rule. So here in this case, I increase the power by 1. So it'd be x to the 8th divided by the new power, which is 8. Then minus 3 times, for that x to the negative 4, I increase the power by 1. So negative 4 plus 1 would be negative 3 divided by negative 3 plus integral of 5. And what I should have done here was pull the 5 out in front. So let me fix that. Here we go again. Five goes in front times the integral of 1 dx, which will end up being 5x. Because you got the 5, the integral of 1 dx will just be x. And then, of course, plus c. So now capital F of x will end up being, if we simplify all of this, let's see, x over x to the 8th divided by 8. Negative divided by negative will be a plus. and those threes divide out, you're left with x to the negative 3 plus 5x plus c. This is what we call the general solution. That is the general solution here. Now let's find the particular solution using the initial condition. We are given that f of 1 is equal to 0. So here we got f of 1 is equal to 0. Now what does that really mean when f of 1 is equal to 0? It means this: at x is equal to 1, capital F of x will be equal to 0. That's your x, and that's what f of x is. X is equal to 1, f of x is equal to 0. So we're going to substitute the f of x with 0 and substitute each and every x with 1. So when I simplify this, f of x will be 0. That's equal to x is going to be 1, so it'll be 1 to the 8 divided by 8 plus 1 to the negative 3rd power plus 5 times 1 plus c. Because we're trying to find out what c is, which will help us write the particular solution for this initial value problem. 1 to the 8th power is going to be 1. So I have 0 is equal to 1/8 plus, now 1 to the negative 3rd power. If you were to write that using positive exponents, it would be 1 over 1 cubed. And 1 cubed is going to be 1. So 1 divided by 1 is 1. So 1 to the negative 3rd power is 1 plus 5 times 1, which is 5, plus c. Now 1 plus 5 will be 6. So I have 0 is equal to 1/8 plus 6, and then plus c. But if I do 1/8 plus 6, I need a common denominator, which is going to be 8. And to make the 6 over 1 have a denominator of 8, I need to multiply the numerator and the denominator by 8. So 8 times 6 will be 48. 1/8 plus 48 over 8 will be 49 over 8. So I have 0 is equal to 49 eighths plus c. And to solve for c, if I move that 49 eighths over to the other side, it would be negative 49 eighths. So the constant would be 49 eighths. I mean, negative 49 eighths. So now I go back to my general solution up here and just substitute the constant c with negative 49 eighths. So I'm going to end up with f of x equaling to x to the 8 divided by 8 minus, and I'll go ahead and write x to the negative 1/3 as 1 over x cubed using positive exponents, plus 5x. That constant is substituted with, I'll say, minus 49 eighths. This right here represents the particular solution. Okay, for that initial value problem. Okay, you have to first do your integration to find your general solution, and then do your substitution of the x and f of x that's given to you in order to find your particular solution. Here's another example. Let's say we had this. For the following function f, find the antiderivative that satisfies the given condition. Here we got f of u is equal to 2e to the u plus 16, and f of 0 is equal to negative 3. So here's our initial condition right here. F of 0 is equal to negative 3. Initial condition. So to find capital F of u, we have to take the integral of f of u du. Since our constant of integration, not constant, variable of integration is in terms of u. And f of u is that 2e to the u plus 16. So here I'm going to have the integral of 2e to the u plus 16 du. All right, and in this case here, we'll integrate each piece by doing this. I'll pull the 2 out in front times the integral of e to the u du plus pull the 16 out in front, so it'll be 16 times the integral of 1 du. And then the integral of e to the u, the integral of e to the u would be e to the u plus 16 times the integral of 1 du would just be u plus c. So in this case here, f of u will be 2e to the u plus 16u plus c. We call that the general solution. All right. Now we got our initial condition that's going to help us find the particular solution. Here we got f of 0 equal to -3. And what that means here is this. X is 0 and f of x has to be equal to -3. So I'm going to substitute my f of u, not f of x. Since we're dealing with u in this case, that means u is 0. And f of u is equal to -3. So f of u will be replaced with -3. That's equal to, and each u will be substituted with 0. So I have 2e to the 0 plus 16 times 0 plus c. Well, e to the 0 is 1 times the 2 will be 2. 16 times 0 is 0, and then plus c. So I have -3 is equal to 2 plus c. And to solve for c, I subtract 2 on both sides. So that means c is equal to -3 minus 2, which is -5. So that means that f of u, I'm going to go back up here and substitute that c with that -5. So f of u will be equal to 2e to the u plus 16u minus 5. This is our particular solution. Okay. And finally, say we had this, we want to find the solution to the following initial value problem. Here we got g prime of x is equal to 7x times the quantity x to the 6 minus 1/7, and g of 1 is equal to 1. So here's our initial condition, g of 1 equaling to 1. And I'll go ahead and say this. If, since we're dealing with x is equal to 1, then that means g of x has to be equal to 1. But let's find out what g of x is. Since we got g prime of x, g of x, of course, is just taking the integral of g prime of x dx. And here's g prime of x, excuse me, that's the integral of 7x times x to the 6 minus 1/7. And I'm putting that in bracket dx. All right, now if I distribute the 7x over dx to the 6 minus 1, 7, here's what I'll have. I'll bring down the integral of 7x to the 7 minus x dx, because 7 times 1 over 7 gives me 1. Okay, and I'll be left with just x, because 7x times 1, 7's divide out, you'll be left with x. All right, now what I'm going to go ahead and do here is I can break each piece up. Bring the 7 down in front, take the integral of x to the 7 dx minus the integral of x dx. And in this case here, increase the power by 1 in x to the 7, there'll be x to the 8 divided by 8 minus, for the x integral of x dx, increase the power by 1, there'll be x squared divided by 2, and then plus c. So that means that g of x would be equal to 7/8 x to the 8 plus minus 1/2 x squared plus c. This right here is the general solution. Now we're going to use the initial condition to find out what our particular solution is going to be. X is equal to 1 and g of x will be equal to 1, since g of 1 does equal to 1. So for g of x, I'm going to replace it with the 1. So it'll be 1 equaling 2. And for each x, I'm going to substitute that with 1. So it'll be 7/8 times 1 to the 8 minus 1/2 times 1 squared plus c. I'm finding out what that constant is. That will help me obtain the particular solution here. Well, 1 to the 8th is going to be 1. Times 7/8, so it will be 7/8. So I have 1 is equal to 7/8 minus 1 squared is 1 times 1/2 will be 1/2 plus c. Now I need to do 7/8 minus 1/2. If I find the common denominator, it'll be 8. To make that 2 and 8, I need to multiply the numerator and the denominator by 4. So it'll be 4/8 from 7/8, which will be 'Oh, did I do something wrong here? I was right, 3/8. Thought I did something wrong here. 7/8 minus 1/2, that came out to be 3/8 plus c. And again, you can use your graphing calculator if you want to do 7/8 minus 1/2, and that will give you 3/8. All right, so to solve for c, I need to subtract 3/8 on both sides. So that means c is equal to 1/8 minus 3/8. 1 whole is 8/8. 8/8 minus 3/8 will give you 5/8, which would be what c is equal to. So going back to this equation right here, g of x, I just substitute the c with 5/8. So it would be g of x equaling to 7/8 x to the 8th minus 1/2 x squared plus 5/8. This represents the particular solution. Okay. All right, so that definitely concludes this video, this 4-part video on section 4.9 dealing with antiderivatives. Feel free to contact me if you have any questions about any of the problems that were presented in this video and the other 3 parts of this video, or if you have questions about the homework in my math lab for this section.